Hi, my name is Adnan.
My name is Taha.
I'm Rishi, and we did our project on gesture recognition using TinyML.
My contribution to this project was data collection and pre-processing.
I'll oversee the neural network model tuning as well as programming the Arduino IDE.
I was in charge of the Arduino integration and power management.
So this is the exact Arduino chip we use, which was a Nano 33 BLE Sense Rev 2. The reason we use it is because of its low cost, as well as it acting quickly and locally without the need of the internet. So our overall project was classifying between three gestures, which was idle, flex, as well as punch. So we collected this data using Edge Impulse, pre-processed that data in the same software, and then we chose important features. And based off those features, we trained a neural network model that classified between those actions.
So this is Edge Impulse. It's basically the GUI we use for this Arduino. And as you can see, we have three sample gestures. Like you said, we have idle, we have punch, and we have flex. So these are three different gestures that the user can do. Each one of these is being sampled at a length of 1 minute and 10 seconds per gesture. And here we have the raw data. It's basically the XYZ values of all of the accelerometer as well as the gyroscope. And this is basically tracking your hand. It's basically tracking the Arduino in 3D space. So it just collects the XYZ values of your hand. And what we do with this raw data is basically we label it. So in this case, we're labeling flex, idle, or punch. And that's labeled by the user. And then that labeled data basically goes in and gets pre-processed by Edge Impulse. And the feature extraction part of the process is essentially the user choosing what features they want to use with the Arduino. So for example, some Arduinos have voice recognition. Some have like Bluetooth connectivity. These are features that we don't exactly need for this project. So we extract those features and we only use the accelerometer and the gyroscope. And so these features are basically fed in to the training model, which is the neural network that's used for this data. And we'll get more in depth with that later on. But basically, this is how the machine learning algorithm works. So the raw data is given to the machine learning algorithm, and 80% of that data is the training data. So what the machine learning algorithm does with this data is it creates a bunch of associations between the input, and these associations between the inputs is called a rule set. So it creates rules to basically predict what the outcome is based off of the input, and that's the training phase. And then the rest of the data, which has not been used to train, is given and is put into the rule set. And using the rules, we predict what the outcome is based off of the rule set that we defined by the machine learning algorithm. So in this case, we're basically taking the raw data and we're creating a rule set to predict whether the gesture is a punch, whether it's idle, or whether it's a flex.
So I'll be talking a little bit about Edge Impulse. So this software allowed us to feed the raw data in, as well as connect to the sensors on board of the Arduino. So Edge Impulse is kind of used by developers, engineers to create solutions with real-world data. So it'll build, deploy any kind of algorithm onto any kind of embedded system. So after we train the data, here you can see it would take a 2-second interval of the continuous function. So take a discrete interval and it would find the average of the data. You'd use a low pass filter as well as RMS to find the averages. After it find the averages, it would feed those features into the model. And then Edge Impulse would provide a model file that we can put directly into our Arduino IDE. So here's the actual model file that was used to classify the gestures. Here we can see that we use TensorFlow Lite. TensorFlow Lite is a neural network model that's designed to run for low memory microcontrollers. Here we can see the actual hard-coded values of the neural network. We can see there's 2 dense layers that use the ReLU activation function. And here we can see this is the accuracy of the training set. We have 99.4% accuracy. And on the right-hand side, we can see the actions, flex, idle, and punch. And we can see a couple of incorrect values, but it's completely normal.
So this image illustrates how the PSD features are fed into a neural network. The network processes these features through its hidden layers, and finally, the softmax layer assigns probabilities to each gesture class. In this photo, where it's written apples, bear, and candy, our system would have punch, flex, and idle. This ensures the system reliably recognizes the most likely gesture, combining data from sensors for accurate real-time probability. So this section of the code begins by including several essential libraries, such as the bolded library, which contains our neural network model. This library allows the edge impulse software to process sensor data and classify gestures like punch, flex, and idle using the trained model. The code defines a structure to manage the initialization, data polling, and status of each sensor. These sensors collect raw data such as acceleration gyroscope, which are then processed by our neural network for real-time gesture recognition. This setup ensures seamless integration of sensor data into the classification pipeline. So this image shows the real output on the Arduino serial monitor. Here, the system displays classifications such as punch, flex, and idle, along with their associated probabilities. This demonstrates the complete pipeline from data collection to gesture recognition running efficiently on the Arduino platform.
Now I'll be doing a live demo of the Arduino. This is the exact Arduino that we've been using. It's already plugged into my computer. To save time, I've already deployed the Arduino code directly on, and now I'll perform a couple of gestures. So now I'm going to flex, and we can see that it has a 99% probability of me flexing. Now I will punch. And we can see that it has a 89% of me punching. So this basically encapsulates our entire project. Thank you for watching.